Hello everyone. So in this video we're going to look at mpsc, which we've already looked at in an earlier video. We're going to look at RW lock, we're going to look at using WebSockets, we'll test it out using WSCat, I believe it's called. We're going to use Claude and also ChatGPT. This is pushing the limit of what I've done recently, but also we will do some, or I will do some research at the end and just verify that what they're coming up with is suitable. I think in terms of it working or compiling, it does. I've already checked that, but there's always a question mark over, could this be done a better way? Could it be made more performant, more secure? So yeah, with all that intro out of the way, let's actually look at the code. I should actually version it, and then I don't know what version I was working with, but right. npx wscat-c. You have to install wscat. You won't normally have it on your Linux machine. Okay, so we'll do tmux again. And there we go. So you can see that was the better version before I asked ChatGPT to refactor it for me. So whatever you type in one gets broadcast to, they both get it. So this is from second session. And you can see they're both seeing it. So this is broadcasting, and that's the whole point, because one of the ideas I've got is, I'm not going to share it here, but it's to do with broadcasting so that everybody can see what's being discussed. So yeah, like a chat room. So that's using Arc and Mutex. My question to ChatGPT was whether we actually needed to be using Mutex. So let's just paste. We'll ask it again. I'm aware of this new phrase called vibe coding, and yeah, I've not really watched any videos about what it is, but if this is vibe coding, then so be it. So look at this code. You are a senior Rust developer. Can you see any way to improve it? Just over here, you can see Claude actually produces you mermaid diagrams or flowcharts. And I think that's quite impressive. It's if you go to the code, it will do you the code as well, so you can recreate it. But so yes, main loop, start the server, build the TCP port, initialize client's map, accept TCP connection, spawn new task for connection. So that's standard sort of server stuff. And then handle connection, upgrade to WebSockets, split into read-write streams, create message channel, generate client unique ID, register client in a map. That's using a HashMap, like a Python dictionary if you're from the Python world. Concurrent tasks, notify owners about join, others about join. And then you're either reading or you're writing a task. So I think that's fairly accurate. Right, let's put my code back in here and see what improvements we'll get to this code. I'm interested to see if it can, you're using unwrap, which is a blocking operation inside async code. This can lead to thread starvation in the Tokyo runtime. Yeah, so it's not like in the use of unwrap, which is to be expected. String conversion between string and message is inefficient. All right, I'm hoping it's at least before I run out of messages, I'm hoping it's right. Yes, it's replaced mutex with RW lock for better read concurrency. That was what I was getting at. That's what I was hoping it would do, because I suspected that. ChatGPT suggested that, and used async locks instead of blocking ones. Proper error propagation, message. Added Tokyo Select. So Tokyo Select stops once it's got something. Proper task management, better error handling. Right, let's try this. We can always do the old git restore trick again if it breaks the code. Distro, so this is not quite set up correctly how I would like it, but it'll do for now. First thing, is it going to compile okay? Yeah, right. I also need to set up my Tmax because it's got those horrible key bindings where you use Control B and it almost takes two hands. Control. Right. So I'll start the web server up here. And then if we get down here, we'll do the mpx wscat-c. That would make such a great alias in in your bash RC or ZSHRC. Right, so connected on one. Let's get across to the other. Nah. The delays on Tmax are a bit annoying, or they need some fine tuning. So, right, session. Let's call 2. Tommy 2, and then Fred 1. So you can see whatever that gets typed in is either a read or it's broadcast. So in the white is what I'm sending in. So this one was transmitting that, and this one was receiving it, and this one was receiving it. So broadcast. It's taking exit as the message.